When we imagine planets and other space objects, our imagination often paints them as sterile and abstract lumps of rock. However, in reality, they are entire worlds that, like Earth, have unique characteristics and features. To get a feel for this, let's mentally transport ourselves to Jupiter and try to understand what would happen if you blinked and suddenly teleported to this planet. What would you see, what would you feel, and what would your future hold? We will consider various scenarios for transportation so that the story does not end in instant and painful death. Let's start with landing on Jupiter in your home clothes and gradually move on to serious colonization expeditions. First, a little background on what Jupiter is. It is the fifth planet from the Sun and the largest in the solar system. More precisely, it is a gas giant whose size is beyond imagination. It can contain all the other planets in terms of volume, and would still be more than twice as heavy as all of them combined. Jupiter is more than 1,000 Earths packed together, and its gravitational force is so great that the planet does not simply revolve around the Sun. The center of mass of the system lies outside the Sun. At one time, it was popular among astronomers to assume that Jupiter was a failed star. After all, 85% of the star systems known to us are double, triple, or even quadruple. Moreover, more than half of the Sun-like stars known to us are double and have a companion. So our Sun is more the exception than the rule. According to the logic of the structure of the universe, systems like ours should more often be binary. This is what once led some scientists to call Jupiter a failed twin star of the Sun, since it consists mostly of hydrogen and helium, the same materials found in our star. Fortunately for us Earthlings, Jupiter was not massive enough to collapse under its own gravity and start nuclear fusion, turning into a star. Nevertheless, all calculations indicate that Jupiter is slowly but surely continuing to contract. It may not be destined to become a star, but there are celestial bodies in the sky that are roughly similar in size to Jupiter. They are called brown dwarfs. A pair of such objects is the third closest star system to us after Alpha Centauri and Barnard's star. The third closest system to the Sun is Lumen 16, consisting of two brown dwarfs that are tiny by stellar standards, weighing only 30 to 50 times more than Jupiter. For comparison, our Sun, which is not the largest, weighs about 1,000 times more than this planet. So Jupiter is truly massive, and we will learn about its other features as we simulate your journey to its surface. Let's assume that you have landed on Jupiter's surface unprepared, wearing your everyday clothes. In this case, things are looking very bad. To be honest, it is difficult to even determine what exactly will cause your death, but we can say for sure that it will not be a lack of oxygen. According to scientists' calculations, even in Earth's orbit without a spacesuit, a person has a good chance of survival and recovery within a few tens of seconds. Ordinary clothing is sufficient to prevent instant burns from radiation. Blood is under its own pressure, and scientists are still debating whether it would boil immediately or not. But even if it did, it would not happen instantly. The saliva in your mouth would definitely boil if you opened your mouth, and if you took a deep breath, it would end badly. However, this is not so important for us. It is only important to understand that the absence of oxygen in Jupiter's atmosphere is far from the first thing that will kill you. For that, you will have time to feel something. For example, a light breeze with a temperature of minus 150 degrees Celsius and a speed of about 1,000 kilometers per hour. At the poles, according to the latest measurements, speeds can reach 1,500 kilometers per hour. That's 3 times faster than the most powerful tornado ever recorded on Earth. In 1996, in Oklahoma, the wind blew at a speed of about 480 kilometers per hour. Multiply that by 3 and add the extremely low temperature. Jupiter's atmosphere consists of helium, hydrogen, ammonia, and clouds of ammonia ice. The conclusion is obvious. You will most likely be swept away, killed, and torn apart by the wind before you feel anything else. The good news is that you don't have to worry about the lack of oxygen. Jupiter's atmosphere is heterogeneous, and the weather there also changes. The planet's famous belts and storms that have been raging for centuries are proof of this. Let's say that in the few seconds you were conscious, the ice clouds flying at breakneck speed didn't kill you. Then you'll be faced with good news and bad news. The good news is that Jupiter's gravitational pull is not that strong. It is 2.4 times stronger than Earth's. This means that your hypothetical 100 kilograms will feel like 240. It's heavy but tolerable, and not enough to cause instant death. Unfortunately, you won't be able to enjoy this fact while standing on the surface of Jupiter because it simply doesn't have a surface. You haven't forgotten that the planet is called a gas giant, have you? It wasn't given this name for no reason. Jupiter's structure can be described very briefly. What we see from the outside as its surface is gas, clouds of ammonia, winds, and other phenomena that would kill us in the previous scenario. Then the real magic begins, because there is no clear boundary between the end of the atmosphere and the beginning of the planet itself on Jupiter, because it is a gas. Having miraculously survived the storm, the last thing you will feel before death is the sensation of falling into a gaseous environment. You will not live to see the next exciting stage, but out of politeness, we will describe it for your lifeless body. School physics inexorably states that an increase in pressure leads to the compression of objects, which in turn increases the temperature. Jupiter is no exception. Gradually, under the weight of the insane amount of gas above, the gases in the lower layers first turn into liquid. Scientists do not rule out that, at some stage during our descent into Jupiter, we may even encounter droplets of liquid water, but they will drown in liquid hydrogen and helium. The layer where all this smoothly transitions from gas to liquid is only 20,000 kilometers thick. Then the real magic begins. By this time, the hydrogen is already under the pressure of an unimaginable amount of gas and liquid, and when it reaches a pressure of 1 million atmospheres and the accompanying insanely high temperature, it begins to exhibit the properties of metal. The next 45,000 kilometers your lifeless body will spend in liquid and then in metallic hydrogen, at temperatures of about 6,000 degrees Celsius. If, by some miracle, even a speck of matter remains of you, it will theoretically hit the solid core. According to scientists' calculations, Jupiter's core is rocky and about 1.5 times larger than our Earth, which on a planetary scale is like a pea in a watermelon. Among the other sensations you would experience in this scenario, the smells are worth mentioning. Slightly above Jupiter, the ammonia would make it smell like urine, and slightly below like urine and rotten eggs. The heavier layers contain hydrogen sulfide and smell like rotten eggs again. And the densest layers, according to scientists, contain hydrogen cyanide, which smells like bitter almonds or marzipan. Considering the odor problems in the previous layers, this can be considered an achievement. That's the end of that story. But let's say you learned from your failed attempt to travel to Jupiter, became a scientist, and created a spacesuit and spaceship capable of withstanding all of the above effects. After reading Carl Sagan and other scientists, you chose the most favorable place to hover above Jupiter's violent hydrogen ocean and, so to speak, colonize the planet, settling in a rare layer of the atmosphere consisting of a cloud of water vapor. Carl Sagan himself even came up with 3 hypothetical life forms capable of existing in these rare layers of Jupiter's atmosphere: sinkers, floaters, and hunters. They are distinguished by their lightness, which allows them to balance in the clouds and not fall into the merciless and hot lower layers. Let's say you've colonized Jupiter and are looking for new forms of life. What next? By now, you probably understand where we're going with this. After a fairly short time, you will die. It's hard to say exactly how long because radiation will kill you, and radiation is an unstable phenomenon, especially on Jupiter. But there is simply an insane amount of radiation on Jupiter. It is important to understand that it does not come from the planet itself. Jupiter, like other bodies in the solar system, is not a walking Chernobyl. It simply has a magnetic field that captures charged particles from the sun and other sources, holding them captive. These particles are what we call radiation. An absolutely identical process occurs on Earth. Our planet also has a magnetic field, but the scale and principles of operation on Jupiter are much greater, and accordingly, the lethality is significantly higher. According to estimates by respected scientists, even on Jupiter's rings within the planet's radiation belt, you would receive 18,000 Roentgens, 20 times more than the single lethal dose for humans. No spacesuits or spaceships could protect you from such radiation. The Galileo probe, just approaching Jupiter's orbit, recorded a radiation dose 25 times higher than the lethal dose for humans. To protect the electronics of the Juno probe, engineers had to place it in a container with thick titanium walls. And that's for a probe flying at a respectful distance from the planet. To protect yourself from radiation directly on Jupiter, you would have to use a decent amount of Earth's titanium, and, if possible, never leave your base under any circumstances. Which, of course, would negate the entire benefit of colonization. Spoiler alert, the same rule applies to Mars and most other planets. Perhaps the main obstacle to space colonization is not so much the harsh living conditions as radiation itself. It is also the reason why the movie The Martian with Matt Damon is implausible. The poor guy couldn't have walked around on the surface of Mars for so long. Radiation would have killed him much earlier. Therefore, when talking seriously about missions to other planets, scientists most often discuss underground colonies. After all, the surface in any form provides protection from radiation. Among other things, an underground base will not be as susceptible to temperature fluctuations. If you are planning to go to Mars, be prepared to either invest billions in radiation protection or bury yourself underground. As for Jupiter, it does not look like a place for humans to visit with modern technology under any scenario. Even in the best-case scenario with preparation that takes into account all known factors, you would travel there like a child, wrapped in multiple layers of protection. And the whole point of visiting would be lost, because leaving the protection would be equivalent to death. Modern optics allow us to enjoy Jupiter from afar, and the dirty work of collecting samples and taking pictures will easily be done by robots in the future. From the point of view of space exploration, they are more promising than we are. But there is no need to be discouraged. Jupiter has many moons where water, metals, and other materials essential for colonization can be obtained. And on some of them, the radiation levels are quite favorable for human biology.